Hi friends, welcome to another video of Codelligent. In this video, we'll be exploring delegates in C#.NET. So these are topics which we'll be covering today. First, we'll see what exactly is simple delegate. Then we will see how we can create anonymous methods using delegates. Then we'll understand what is multicast delegates. And then we'll see how we can create callbacks using delegates. Then we'll see how we can make extensible and flexible applications with the help of delegates. And finally, we'll just touch upon action and func. So let's start with simple delegates. So what exactly is a delegate? As per Microsoft, a type that represents references to methods is nothing but a delegate. Or we can say in different words like an object that knows how to call a method. This is actually very helpful while designing extensible and flexible applications, so that we will be seeing very soon. So on the right side, you can see how we can create a delegate. .NET provides the keyword delegate. So you can see this explanation here. So we are creating public delegate. The return type is void and the name of the delegate, and the parameter is string message. So what exactly this means? So this means this delegate is an object or a reference which can take any method of this signature. That means any method which is having a void return type and a single parameter of string type can be assigned to this delegate. So we can use this delegate in this way. We can say print delegate, the name of the delegate which we gave, and some object instance name, and we can assign any method of this signature to this particular instance. And how we can call this? By just invoking this object and passing the parameter. So let's see in action how exactly it works. So I am in Visual Studio, and this is a simple console application which I have created, and in the main method I have just one statement, console.readline, that is, it will wait for my input from the console. So let's start with creating a delegate. So when you say public delegate, you can see there is a keyword which the .NET is offering, it is delegate. Then I have to tell the return type. As of now, I'll keep it as void. Then I'll create maybe my delegate. This is the name of my delegate, and then I have to tell what are my parameters. So as of now, I will not pass any parameters. So it is a simple delegate. Now I'll create another method, public static void, maybe you say with method 1, and in which we are doing just a simple console write line saying this is method 1. So now I can create instances of my delegate by just saying that my delegate d1 equal to, I can assign any method which follows this signature, that is return type void and takes no arguments. So this method satisfies that. So I can just say method 1, and to invoke that I can say d1, and that's it. This is the way you create a delegate and invoke it. So when you run it internally, it will call that method. Now suppose you want to change the signature of this method. I want to pass a parameter int I, so I have to change the signature of the delegate also to take a parameter, maybe say I'll change the name, so int type, and when you are calling the instance of the delegate, you will pass a value. So when you run, it calls. Oh, so to verify that, we can print this value here. Maybe I'll print I here. So now when you check, you can see the value which you have passed while invoking the method. So this you can call multiple times by passing different values. d1, again I'll call with some 45. So now I've called 3 times. So you can see the method has been called 3 times with different values. So this is how a simple delegate works. This delegate is helpful in creating anonymous methods as well. For example, if you think this method is too small and you don't have much functionality here and you don't want to create a separate named method, there is a way you can create an anonymous method as well. So let's see an example for that. I'll remove these methods and these from here. I am changing my delegate such that it returns me an int and takes one int, and here I'll create the instance, for example square, and here I'll create the anonymous method. So for that you need to use keyword delegate, which takes an argument of int type, and I'll give the body of the method here itself. So this will return me n into n. So that means I am taking the square of the method. I can create similar way one more instance of my delegate which says cube, where again I'll use the anonymous method which takes int n, and this guy returns me n into n into n. So this gives me the cube. So now wherever you want to call these methods, you can use this references of delegates. So for example, I can say console.writeLine square of 5. I can say console.writeLine cube of 5, and I can say console.writeLine maybe again cube of some 7, and just run it. So you can see the value 25, 125, 343. So this is how you can create anonymous methods using delegate. Now since that you have understood what exactly is simple delegate, let's see what is multicast delegates. So it is just an extension of the simple delegates. So multicast delegates is nothing but multiple objects of delegates can be combined together using plus operator. So like how you do arithmetic operators on int type, you can do on delegates type, and you can do even minus operator to remove the delegates. So once multiple objects of delegates are added together and you call that delegate once, all those which are added into the list will be called. So you're not clear with it? Let's see an example. We have a delegate called print delegate which returns void and takes one message. I have any method which has the same signature. If I have 3-4 methods, so I can use them like print delegate instance 1 as method 1, print delegate instance 2 as method 2, and I can create print delegate instance 3 which adds these two delegates. So that is instance 1 plus instance 2. And when I invoke instance 3 with some parameter, internally it invokes both of them. So let's see this work in action. I am in Visual Studio and this is one simple console application. So first I'll create a delegate, public delegate, I'll return it as void and I'll name it as delegate, and this guy takes maybe a int parameter. And in the simple delegate section we have seen how we can create simple delegates for this. So like my delegate d1, and I can assign a method. So instead what I'll do, first I'll create two methods, that is public static void maybe method 1 which takes int I, and I will just print method 1 and the value which I have passed, that is I. So now I'll just copy this and create one more method, and I'll name it as method 2, and I will print method 2 on the console from this method. Now I'll create 3 references for my delegate, and this should be d2. Now what I'll do is d1 I'll assign method 1, d2 I will assign method 2, and now when I say d3 I will say d1 plus d2, that is combining these two instances into one. Now when you invoke d3 with suppose a value of 5 and you run this, you will see both method 1 and method 2 getting called with the same parameter value. So this is how a multicast delegate works. So you can, instead of the plus operator, you can use minus operator also. So now as you know that d3 contains both d1 and d2. Now I want to remove d1 from this list, so I'll say d3 equal to d3 minus d1. So now from this d3 list, d1 will be removed, and now if I call d3 with some different value, and when you run, you can see only method 2 gets called because method 1 has been deleted from the list. So this is how you can perform plus and minus on delegates. So this can be shortened it. Normally in usual applications we don't use these kind of methods additions. We normally use plus equal to operator, so that in with integer parameters you can use I is equal to I plus 1 as I plus equal to 1. So that means if I have d1 which I want to say d1 plus d2, instead of writing like this, I can say d1 plus equal to d2. So this is a shorthand way of writing this particular statement. So we can use similar way, that is, I'll remove all these and I'll keep only one reference, that is d1. Now I'll say d1 equal to method 1, and then I'll say d1 plus equal to method 2. And for just a demo purpose, I'll create one more method, say method 3, and I'll just print method 3, and here I'll say d1 plus equal to method 3. So now I have assigned 3 methods to one delegate reference. So now when I invoke d1 with some value 7, you can see all the 3 methods get called. And similarly, even you can use d1 minus equal to, and I'll remove method 2, and I'll again call d1 with some different value. So now you can see only method 1 and method 3 getting called. Method 2 has been removed from the list. So this is how a simple multicast delegate works. Now let's see how we can create callback methods using delegates. So what exactly is callback? As per Wikipedia definition, callback is an executable code that is passed as an argument to another code that is expected to call back or execute the argument at any given time. Let's try to understand this with an example. I'm in Visual Studio and this is a console application. So this is the default class program and I have a main method. Suppose this is another library and in that some class is there, and there is a method which does some very time consuming work. So basically this does some big work. So this can be in the real time, like might be you want to access some server or call some web APIs or contact the database or read something from the network or whatever, like which takes a lot of time. So normally in general case, when you are doing such type of thing, you don't want your main thread, or in the case of a GUI application it will be the window, you don't want the window to freeze and you don't want the main thread to wait till this work is completed. In such cases you create a thread and call this method using a different thread. But suppose after calling this guy does some work and that result you want to send it back to the main thread, or in the case of a UI you want to pop up a message saying that the data is so and so which we have retrieved. So in such case delegate comes into help, and such kind of calling of methods is called callback. So from here I'll create a thread and start this method, but once this work is done I will give a call back with some data to my main thread. So to do that, in this class we will create first a delegate. So a public delegate void, maybe some name called work handler, and this guy expects some int I variable. So this can be anything, like I want to return a int type to the calling method, so that's why I have used int. It can be a string or whatever type of data you want to send back. So here, to do some big work, I'll use thread.sleep of 5 seconds. So this simulates a very big work, and this method expects a work handler type method to be called. So that means whoever is calling this method from anywhere needs to pass a method which satisfies this signature of having a return type void and a parameter of int type. So if that kind of method is passed to this method, it will accept it. And at the end, after doing the work, I'll simply call this method with whatever value I want to return it. So in this case, I'm just passing a dummy value. Maybe that value will be like extracted from the database or get it from the server or network, whatever. That value you will pass back to this method. So you are calling this method with that. Now from the main, what we will do is, first we will create the object of this library class. So that is maybe some object equal to new object, new class, and I will say maybe I can start a different thread. So I'll say var t is equal to new thread, and I'll use lambda expression. So if you're not clear with lambda expression, you can check out my other videos where I have explained lambda expressions in detail. So in this method, I'll just call obj dot do some time consuming work, and it expects a method. So what method I will create here of the same signature which this delegate is expecting. So that is like public void maybe print method which expects an integer, and in this simply I'll print the value. So maybe I can put the value is I, but since we are dealing with static methods, I'll create this method as static so that I can directly use it in the main. And here as a parameter, I will pass this print method. So this is how I create a thread, and I'll simply say t dot start. So now, just to make sure that we are not stuck there, I will say console.writeLine, we are still alive in main thread. So this is a print which happens after the thread has started. So now if you see the flow in the main method, I have used another library class, and in that object, using that object, I have a method which I can call, but I am calling that in a new thread. And this method expects a type of method which should be of void return type and takes an argument of int type. So this is the method which I am passing here. In this class, we are expecting that same method, and I'm doing some big work for 5 seconds, and then just I'm giving a call back to this method with some return value. So now when I call this method, maybe in the beginning I can put one console application console writeLine so that you can see code begins here, so that in the console we can see something is happening. So when I run this, you can see first it will print code begins here, and it goes we are still alive in the main thread, so that thread has not been killed, but you see after some time a value has been returned. So this is nothing but a callback. So you are, from this method, you are giving a call to another method, and you are not stopping for that method to return any value. You continue in the main thread, but once the work is done, this method gives a call back to the main thread with some value. So this is how a callback method works. Now we will see how we can use delegates for making flexible or extensible applications. So let's jump into Visual Studio, and this is some console application which I have created, which just has a main method. So now let's see what we can do. You can right click and I will add a new class. Maybe I'll create a class called photo. So since these days everyone is using cameras in mobiles, and everyone will be using applications like Instagram, Facebook, where people keep uploading photos and everyone try to process them, like they will change the color, they will apply some filters, etc. So I'll try to replicate that similar scenario here. So maybe as you can see, the program.cs is in namespace delegates demo. I'll create another namespace just to demonstrate like it's in a different library. So I will say my photo application. So I'll have this as a library called my photo application, and in that I have a public class called photo, and this photo has one property called name. So this is nothing but a photo. Now I'll create another class in the same library, which is like process photo, or maybe first I'll create some photo filters. So this is an application which you are offering to customers. So I'll create public class filters, and I'll create public static void some method called apply saturation. This guy accepts a photo, and inside I'll just have a print saying saturation applied to and the name of the photo, so maybe p.name. Similarly, I can have one more method saying apply contrast, and I will say contrast applied to this photo. So this is another one. So I'll move this guy to another file called photofilters.cs. So now we have photo.cs, photofilters.cs, both of them in the same namespace called my photo application. And now I'll create one more class called public, maybe something like process photo. I'll make this guy as public, and here I will have a method called public void process. So this is a simple method. So now the delegates come into picture. Now I want to make this application more robust, so so that when I offer this library to any customer, they can have the flexibility of expanding it. So how it happens, I will show you. Now you create first a public delegate, maybe a void type, and some photo filter handler, and this guy expects a photo type. Now this process method expects a method of type void return type, and which expects an integer and parameter called photo. So I'll use this delegate, that is photo filter handler, and some variable name called handler. So I will also expect one photo argument, so maybe I'll first accept that photo, and with that I'll expect a method. So this guy's work is just to call this handler method and pass this argument to that. So handler of photo, and that's it. So I'll move this class also to different CS file, that is process photo.cs. Now this library, when you give to some customer, so first I'll use the namespace, so name using my photo application. So now I am using someone's library, and here what I can do is I can create a photo class. Photo is equal to new photo, and I'll say photo dot name is equal to maybe some landscape dot jpg. This is just to simulate a real-time application kind of scenario. So now my photo is ready. Now I want to process it. So what I'll do is I will call the I'll have one more class, that is process photo. So I'll say process equal to new process photo, and you know very well there is a method called process dot process, so which expects a type photo. So I can call this by passing the photo, and I want to apply the handlers, so that is some filters. So you know very well we have created already photo filters class, so I'll just use photo filters dot apply contrast. Again I'll say process dot process, and I'll pass the same photo and say photo filters dot apply saturation. Now when you execute this, what you will see is contrast applied to this landscape.jpg, saturation applied to landscape.jpg. So now everything works fine. But now you will have a question, why we have to use this delegate instead? Why can't we clearly directly call that? So what is the advantage which we get by using delegates? The advantage is what you're going to see next. Now if you not have given this delegate and you just have given the option of calling this process method by photo, and internally you would have applied a contrast, the application is limited. You are not giving a scope to extend it. But with this delegate I have the scope of extending it. The customer can extend this application. Like you are not offering something like apply colors, but the customer wants now to extend this same application with applying colors. So what I can do is I can create a public static void method called apply colors, which follows the same syntax of photo some variable. Here what I'll do is I'll print console.writeLine apply, or maybe I'll follow like colors applied from outside the library to I'll pass the photo variable dot name. So now I have the I have a way to extend this. Like I can say process dot process, I'll pass the same photo, but instead of calling now the method from the library, I will call the local method, that is apply colors. And now when you run, you see that contrast and saturation has been applied to that JPG from inside the library, whereas colors has been applied to the same JPG from outside the library. So now you have the flexibility of making this library which you have offered to the customer can extend it however he wants. So this is one of the great ways which Delegate offers you to make flexible and extensible applications. So the last topic for today is action and func. So let's see what exactly is this action and func. As you can see on the left side, I have explained these are inbuilt delegates offered by .NET Framework. So delegates is nothing but reference to any method. So action accepts a method which doesn't return any value, whereas func accepts a method which returns a value. And both action and func can accept parameters from 0 up to 16 parameters. So how you use them is shown on the right side. You can use the keyword action, and in the angular braces you can tell what is the data type. So in the case of action, as I have explained already, it expects a parameter but it doesn't return a value. So if at all you have mentioned something, by default this data type is for the parameter. So I'll say action int some variable equal to a method. So this method should have the signature which returns nothing, that is void, and takes a parameter I. If at all you want to return some method, the value from any method, so for example like this, where you have method 2 takes a double parameter and returns a string, then you have to use func instead of action. So in the func, the first parameter in this angular braces is the parameter type, second one is the return type. So in this func, always the last one which you mention inside the angular braces will be the return type. So for example, in another method which takes double and int type parameters and returns a string, you will have to create it like func double int and the last as string. So this last string always refers to the return type. So let's see how it works. I'm in Visual Studio, and here I'll create a sample method like public static method 1. This guy doesn't return anything and doesn't take any parameters. So I'll say console.writeLine. I'll say this is a method 1. So instead of creating delegates and assigning this, which we have seen in the case of simple delegate and multicast delegates, now I'll say action some act equal to method 1, and I can simply call act. So this is equivalent way of calling how we do it for delegates. So now if we run it, you can see it very well calls the method 1. So this action, once you put angular braces, you can see there are 16 overloads. So first one is t, second one is 2 var parameters, third one is 3 parameters. So like that you have so many overloads up to 16 parameters. So now I'll show you one more method, like for example this is another method called to, which takes int I, int j, int k. So this is like 3 parameters. So I can create an action which takes int, 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 and say act2 equal to method 2, and I can call act2 and this variable executes, but yeah, you have to pass the parameters, so that is like 1, 2, 3. So now when you call, it executes that method. Similarly, if you want to do this for with the return type, so I can just duplicate this code and I'll say method 3 and this is method 4, and I'll print also method 3 and print method 4. But in this case, instead of void, I want it to return int type. In this case, I want to return string type. So in this case, Visual Studio will give error because we have to return something. So I'll say return 2, and in this case I'll say return some xyz. Now if you want to do this instead of action, you will have to use func. So now when you say func, and as soon as you start the angular brace, you will see the first one by default expects a return type. So in the first case, the return type of our method is int, and it is like func1, and I can assign method 3 to it, and I can just call func1, and whatever the value it comes, you can accept it in any variable also. Variable some result equal to func1. So this value which it returns will be taken over here. So when you run, you can see the func1 also is executed. Similarly, if you have more parameters to be passed, you can say func, and in this case you have 3 int parameters and 1 string return type. So you'll say int, 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 and string. So this will be func2, which is assigned with method 4, and you can call the method as func2 and pass 3, 4, 5. So now if you see, this parameter takes 3 int variables and returns a string type. So when you run this method, it very well executes. So this is how a func and action you can use, which are like inbuilt delegate types in .NET Framework. Thank you.